Hello people, this is Jasneet Singh aka Innovative Coder from Innovative Coder Workstation, and to continue our video session, the pin diagram we were doing, right, 8085 microprocessor pin diagram we were actually doing. So now we have completed these pins, and now we'll be doing the right side of the pins of our 8085 pin diagram. So first thing is 8A8 to A15. So these are address lines, right? These are actually address pins from which the bus will be connected. And here we have the multiplex pins, right? AD0 to AD7, which can carry address as well as data. And how will you know what it is carrying? Through ALE, right? I hope you have seen the previous video in which we talked about ALE. Okay, so you'll be you can carry address or data through AD0 to AD7. I think I have written ALE over here, but it is not present, right? Okay, I by mistake did that. ALE, right? Okay, I think I have a serious problem with this diagram, right? So now I think it is corrected. Okay, so here we have this thing. Then we have the SID and SOD pins, which we'll be talking about in the architecture video. So a brief idea, these are used for serial data transfers. What is serial data transfer? When you transfer data bit by bit. So 0, 1, 1, 0, 1, 0, 1, 0, what is your pattern, what is your data? You transfer the data bit by bit. So SOD, serial input in data, serial in data, and SOD, serial out data, right? So for getting the data and for giving out data, right? So we'll be understanding more about this at the time of architecture. Then here we have our 6 interrupts, right? So trap, RST 7.5, RST 6.5, RST 5.5, INTR and INTA bar. INTA bar is not actually interrupt, it is acknowledgement. So these 5 interrupts we have: trap, RST, 3 RSTs, and then INTR. So we'll be understanding interrupts in the interrupt video, which will be a separate video for this particular topic in another session, right? Okay, so this INTA bar is actually an acknowledgement from the device. We give actually the acknowledgement to the device, because if our device generates an interrupt, right, you process the interrupt and then sends solves that interrupt using ISR. See, we'll be understanding what is actually ISR and what all are these things, and then you send the acknowledgement that your interrupt is received and your interrupt is processed. Then you send an acknowledgement to the device using INTA bar, which is an active low signal. Okay, then we have hold and HLDA commands. So hold and HLDA, which is hold and hold acknowledge signals. They are used for DMA. What is DMA? DMA is direct memory access. We'll be understanding about DMA in detail in a separate video or maybe in a collaboration video, right? But what is DMA? DMA actually is, so what are hold and HLDA pins? So DMA controller issued the hold signal to microprocessor. So there is a DMA controller in our when we use direct memory access, there is a DMA controller, right? And this is what issues the hold signal. In response, the microprocessor releases the system bus. After releasing the system bus, the microprocessor acknowledges the hold signal using HLDA, this HLDA signal. I know you might not get the complete insight. This is a basic idea of what is actually hold and HLDA pins used for. So a simple thing, they are used for direct memory access, DMA, right? DMA transfer is terminated by releasing the hold signal. That's it. We'll be understanding DMA in complete detail in another video, right? So by this, actually we cover the complete 40 pins. So just a quick revision of all these pins. So X1 and X2 are oscillator pins, crystal oscillator pins, which are used to give the clock pulse, right? Then we have clock out to give the clock out to other devices. We have reset in bar and reset out. We have ready, we have ALE, we have IO/M bar to tell whether it is an IO operation or a memory operation. Then we have read bar and write bar, which are the control signals and not actually the read and write operations, right? Which both are active low signals. Then we have S1 and S0, which are used for serial communication, right? Yeah. No, oh, sorry. S1 and S, these are not, I confused SID and SOD, sorry. So we have S1 and SO, which are also known as SI and SO, S input and S output. Known. They are not actually S input and S out, they are actually S1 and S0, and they tell the status of the microprocessor, right? We'll be understanding about S1 and S0 in timing diagrams, right? And then we have VCC and ground. So we complete the left side, then we on right side we have A15 to A8, and we have AD0 to AD7. These are the multiplex and these are address. Then we have SID SOD for serial communication, serial transfer. Then we have our interrupts acknowledgement, hold, HLDA for DMA, direct memory access, and that covers our 40 pin IC. So I hope to see you in next video, which will be the architecture videos, and then we'll be covering various other topics of this 8085 microprocessor, coming up with the memory addresses and all of these interrupts, flags, and all of these things. So that's all for this video. If you like the video, then please hit the like button, and if you have any doubt, then you can comment your doubt below. If you have any suggestion, you can just put that in comment box, and thank you.